Okay, in question 26, I just want to clear it up. I don't want you to do all of question 26. It asks for a little too much, and it's asking you to put some things in the calculator. I just want you to do part A, which is construct a stem plot. So find the lowest number. That looks like it would be 4.88, so the stem would be 48. And then the highest number looks like it would be 5.85. So 58 would be the stem. So go from 48 to 58, so 48, 49, 50. That'll be your stems and then your leaves, and make a stem plot. Now, part B, to see how closely it follows the 68, 95, 99.7 rule, put all these numbers into L1, do stat calc, one variable stats. It'll give you the mean and the standard deviation. Remember, standard deviation is that SX, and the mean is X bar. So get the mean and standard deviation. Then you can draw your normal probability curve. Put the mean in the middle, go 3 standard deviations to the right, so add whatever the standard deviation is each time, then subtract the standard deviation each time, and that'll give you the curve. All I need you to do is draw the curve and label those numbers on the bottom so you'll know what they will be. That's all I need you to do for 26. Problem 27 says use the methods of chapter 1 to describe the distribution of these lengths. So it wants you to do some type with those 44 great white sharks. It wants you to do something. Let's choose, I think what we should choose is a histogram. The lowest number that I see here is 9.4, and the highest number is 22.8. So from 9 to 23, so let's think about it. From 9 to 23 is about 15 numbers. So let's go from, we need a couple. So maybe we could go from 9 to 11, from 12 to 14, from 15 to 17, from 18 to 20, from 21 to 23. Okay, and that would be our histogram. Make sure you make the table and do that. B says compare the mean with the median. So put these in list 1 and get the mean and the median, compare it. Does your shape of your distribution, does that match what happened? So if the distribution was skewed left, is the mean less than the median? If the distribution was skewed right, is the mean greater than the median? And if the distribution was pretty symmetric, are they close together? Is it approximately normal? Basically, to see if it's approximately normal, you would just see how much data lies within a certain part of the graph. I'm not gonna make you do that part. You just need to be able to do the curves, so I don't need you to do that part. So we move on to 28. 28 is the z-scores. Remember, if you want to do less than a certain z-score, you never have to use the table. So you never have to use table A, but you do have to round to 4 decimal places. If you want to do less than or equal to negative 2.25, you do a normal CDF. If it's less than, then your lower number is negative 999 and your upper number is that z-score. If it's greater than, then your lower number is the z-score and your upper number is positive 999. If it's in between, then your lower number is the lowest z-score and your upper number is the highest z-score, and normal CDF will give you all of those. Problem 29, again, it says use table A to find the value z of a normal variable that satisfies the following conditions. 70% falling below it, you're going to look at the table here, and what you want to look for is where in here is 70%. So where in the table do you see 70%, and that would give you the z-score that you're looking for there. For number 28, for number 29. If it says 85% falling above it, you got to think below, because that's what the table in the front of the book gives you. So if 85% is falling above it, that's 15% below. So you're going to look inside there, the table there, for 15% and see what z-score gives you 0.15. Find the z such that the proportion of observations are less than z is 0.8. Again, you're looking for 0.8 in your table. So it's just another way of saying 80% goes below. And then find the one that 90% is greater than z. So that means you're looking for the 10% or the 0.10, because 10% would be below. So when you use the table for a z-score, you're always looking at what's below no matter what the problem gives you. So if the problem gives you above, you need to do 1 minus that to get below, and that's what you'll be looking for there. Number 31, in first and second period, we talked about the pregnancy one. The mean is 266, the standard deviation is 16. So make the curve, put the mean as 266, 282, 298, 314, 250, 234, 218, and then how many pregnancies last less than 240 days. So again, for less than, you're doing the z-score. That's x minus the mean divided by the standard deviation. So that's 240 minus 266 divided by 16. That gives you the z-score. If you want less than, you're going to do a normal CDF of negative 999 to that z-score. How many last between 240 and 270? Get a z-score for 240, get a z-score for 270, normal CDF of those two numbers, the lowest and the highest. And then how long do the longest 20% of pregnancies last? That means I am looking for, if it's in the longest 20%, that means it's greater than 80% of pregnancies. So if I go in Table A and look for 80%, the closest one is a z-score of 0.84. Okay, so 0.84 is my z-score, and the only thing I don't have is my x, so it's an algebra problem. So it's x minus the mean, which was, the mean was 266, so it's x minus 266 divided by 16 equals 0.84, and that will give you what x that the longest pregnancies have to be, and that means the longest 20% of pregnancies are that or more, is how long it is. So we go to number 33. 33 talks about quartiles. The quartiles of a density curve are those at 0.25 and 0.75. What are the quartiles of a standard normal distribution? That means look in the table again, look for 0.25 and see what z-score it would be. Look for 0.75 and see what z-score it would be. How many standard deviations away from the mean do the quartiles lie in the normal distribution? So whatever your z-score was in A, that's how many standard deviations away from the mean they lie. So your answer is giving you the same there. What are the quartiles for the lengths of human pregnancies? So go back to the pregnancy problem on 31, and basically you want to find what x is. So you have x minus 266 divided by 16 equals whatever that z-score was for those two quartiles. So that'll be two different problems. For instance, the 25% one, 0.25, the z-score would have been negative 0.67. So that would be your problem. X minus 266 divided by 16 equals negative 0.67, and you would find out which one that is. And then the other one would actually be x minus 266 divided by 16 equals 0.67. So those would be your two quartiles, and you would find out what numbers those actually were. That would tell you where your 25 percentile was and your 75 percentile was. It's just another way of saying that. Number 34, the deciles of any distribution are the lowest 10% and the highest 10%. So that's at 0.1 and 0.9. So again, you want to look in Table A and see where is 0.1 at in the middle of the table and where is 0.9 at in the middle of the table. Not hard to find the z-score there. And then in the heights of young women, so x minus 64 divided by 2.5 equals, and you have those two z-scores. So two problems there, and those will give you the answers. Okay, we go to number 41. 41 is more practice on Table A. Remember, less than goes from negative 999 to 1.28. The greater than in B goes from negative 0.42 to 999. In between goes from negative 0.42 to 1.28. And then less than again in D goes from negative 999 to 0.42. All using the normal CDF. A lot of that will be on the quiz tomorrow. Number 42. Find the number Z such that the proportion of observations is 0.98 that are less than. So I go to Table A and I look for 0.98. That's on the back page, and you can find that. Look for the one that's closest to 0.98, and that'll tell you what z-score that would be. Because it's less than, we look for that exact number. As we move on to B, it says find the number Z such that 22% are greater than Z. Well, if 22% are greater, that means 78% or less. So you look in Table A for the Z-score that has 0.78, and that'll give you number 42. 44, are you a good judge of people? The insight test evaluates how accurately the subject appraises other people in the reference population. Scores are normally distributed. The mean's 25, standard deviation 5. Draw your curve, put the mean 25, and then go your standard deviations 30, 35, 40, and then 20, 15, 10. and it says, what